SQL injection is a widespread vulnerability in web applications. In a previous video, we explored SQL injection using SQLi. If you haven't watched that series yet, you can click the I button to view it now. Today, we're delving into SQL injection without relying on any tools. Instead, we'll employ manual exploitation methods to gain a deeper understanding of its mechanics. To facilitate our demonstration, we'll utilize DVWA, DAM vulnerable web application, commonly found on various vulnerable VMs like Metasploitable 2 and OWASP broken web application, which we've previously installed. In this video, I'll showcase SQL injection using Metasploitable 2 to provide a thorough demonstration. But before we dive into the SQL injection technique, let's first familiarize ourselves with the SQL commands required to access the DVWA database. Let's begin by launching the Metasploitable 2 VM. We'll access the Metasploitable 2 VM from Kali Linux. To do so, we need to obtain the IP address. Keep in mind, the default login credentials for Metasploitable 2 are both msfadmin. To find the IP address of Metasploitable 2, execute the ifconfig command. The IP address of the Metasploitable 2 VM is 192.168.95.8. Return to Kali Linux and we'll use the SSH command line utility to establish access. Now, let's return to Kali Linux. Open a terminal. We'll utilize the SSH command line utility to establish access. Execute the command SSH followed by the username and the target's IP address. Upon execution, you may encounter an error. To resolve it, we'll need to paste the host key algorithm. Once done, proceed by typing yes. To access the MySQL database server, use the command mysql-u root -p. It will prompt you to input the password. Simply press enter to proceed. Upon execution, you'll enter the MySQL command line interface, allowing you to execute SQL queries and manage the database. Execute the command show databases to fetch the names of all databases stored on the server. This information will be displayed in your command line interface or any MySQL client you're utilizing. Use the command use DVWA to set the current database to DVWA. Next, type show tables to display the tables stored within the DVWA database. Here, you'll see two tables listed, guestbook and users. To retrieve all rows and columns from the users table, execute the query, select *symbol from users. The asterisk stands for all columns, so this query fetches every column of every row in the table. It's a quick way to gather all the information stored in that table. MySQL will fetch all rows and columns from the users table and present them as a result set. Data in SQL is organized into columns and rows. You'll observe a series of columns such as user ID, first name, last name, user, password, avatar, etc., with unique entries listed in the rows. It's essential to note that the password stored in the database is not the actual password but rather a hashed version. Hashing is a one-way algorithm that converts the password into an encoded value. This measure is implemented to safeguard user passwords in case of a security breach, as hashed passwords are challenging to reverse back to their original form. These are fundamental aspects of SQL queries for interacting with a MySQL database. Moving forward, I'll demonstrate how SQL injection works. You'll see the web application interface, and from there, you'll need to devise techniques to inject and structure your syntax in a manner that triggers unexpected behavior in the application. To begin, open your browser and navigate to the IP address of Metasploitable 2. Then, access the DVWA, DAM vulnerable web application. You'll need to input the DVWA username and password to access the dashboard. The default username is admin and the password is password. After a successful login, you'll be directed to a dashboard where you can practice and enhance your web hacking skills. Ensure that the DVWA security level is set to low. Now, let's delve into SQL injection. Click on the SQL injection link to proceed with the explanation. In the DVWA application, on the SQL injection page, you'll notice a prompt for a user ID. Approach the application as you would with a regular user. Entering a user ID of 1, you'll observe that it displays first name, admin, and surname, admin. Behind the scenes, when user ID 1 is used, a query is executed on the MySQL database to retrieve the first name and last name. Let's examine the queries executed on the MySQL shell. Execute the query, select first name, last name from users, where user ID equals 1. MySQL retrieves the first name and last name of the user with ID 1 from the users table. This information is returned as a result set, typically containing a single row with the user's first name and last name. Likewise, if we input a user ID of 2, the database will return Gordon and Brown. This process may seem familiar, as we've already explored the backend database. However, under normal circumstances, accessing this data directly would not be possible. Returning to the SQL injection example, our goal is to identify if there's a potential SQL injection vulnerability. To do so, let's introduce unconventional SQL syntax and observe the application's response. Apostrophes are commonly used to test for SQL injection vulnerabilities. In our previous SQL shell session, we used apostrophes to enclose strings passed to the application. Let's observe the outcome when we input just an apostrophe. Encountering a common error message stating you have an error in your SQL syntax often indicates vulnerability to SQL injection. While we'll discuss vulnerability detection further later on, for now, understand that the presence of an apostrophe breaking the SQL syntax implies potential for manipulation. In our previous MySQL shell session, we queried for first name and surname from the user's database where the user ID is 1. Recognizing the possibility of disrupting SQL syntax, we can anticipate potential user IDs and request additional data. Let's experiment with logic manipulation without necessarily disrupting the syntax. To achieve this, let's input an apostrophe that doesn't always break the syntax but may yield interesting outcomes. Knowing that the query is enclosed with opening and closing apostrophes, let's manipulate the syntax. After the where ID equals 1 clause, which verifies if the value in the ID column equals 1 and filters rows accordingly, we'll introduce a logical operator. By using the OR logical operator, we allow either condition to be true for the row to be included in the result set. Subsequently, we'll employ the condition 1 equals 1, which is always true because it compares the string 1 with itself. This condition is frequently exploited in SQL injection attacks to coerce the query into returning all rows from the table. Executing the query, select first name, surname from users where ID equals 1 or 1 equals 1. MySQL retrieves the first name and surname from the users table where either the user ID is 1 or the condition 1 equals 1 evaluates to true. As the condition 1 equals 1 always holds true, this query effectively returns all rows from the users table. Copy the condition that filters the rows returned by the query and paste it into the user ID field. Click on the Submit button to display the same data retrieved previously from the MySQL database. We've successfully gained arbitrary access to the backend database. The next step involves a slightly complex task requiring familiarity with SQL syntax. Our objective is to steal usernames and passwords. SQL queries feature a union SQL keyword, allowing us to merge the results of multiple select statements into a single result set. Utilizing the union SQL keyword, I'll craft another query to select the user and password columns from the users table. The aim is to extract sensitive information, such as usernames and passwords, from the database. Upon execution, the first query is processed, followed by the union query, which consolidates the usernames and passwords into the same column names. Let's test this on DVWA's SQL injection feature. Upon execution, an error message indicates a syntax error in SQL. The syntax presented above may disrupt functionality due to the rogue apostrophe at the line's end, automatically added by the web application. However, the pound sign serves as a comment character, instructing SQL to disregard everything following it. This syntax instructs SQL to provide usernames and passwords from the users table and merge them with the previously retrieved data. Entering this string into DVWA yields the desired data. As observed, we've disrupted the web application's functionality. The initial record, admin, is as expected since we requested the first record with ID equals 1. Furthermore, by querying other users and passwords from the users table, we encountered hashed passwords within the surname field. While hashed passwords are theoretically irreversible, many common passwords hashes are available online. A quick search can often yield the unhashed version of these passwords. Clicking on any of these search results reveals the password. This process provides insight into how SQL injection operates. If you wish to explore SQL injection using an automation tool, I recommend using SQL Map. Refer to the accompanying video for further details. If you have any doubts or queries, feel free to write them in the comments section.